Andrew. Well, I think it's afternoon for most people. Good afternoon or good morning or wherever you are in the world. My name is Kristen Koska. I am a collaborator within the Odyssey community. I also have a day job at a company called IQVIA. But today I'm really here to give you a bit of a crash course in how the OMOP vocabularies work. We've seen a lot of questions posted in Slack and across emails, and we thought it might be nice to have a little bit of a primer. And before I dive in today, I just kind of want to lay out the groundwork for how this is going to go forward. So in the next hour, you will learn a very brief history of these terms you're hearing, OMOP, Odyssey. But more importantly, we're going to have things, so we're going to leave the line open, but we may ask, Andrew, can you help me make sure some folks are muted, perhaps? And so back to our objectives. We're going to talk about how the standardized vocabulary works. We're going to talk about how to find codes and concepts, how to navigate that concept hierarchy, and also just very briefly touch on not just the vocabulary, but also the data model. So I'm going to pause. All participants are muted now, so I think we're in good shape. Andrew, I just want to make sure you can still hear me.
Yep. I guess for some reason folks aren't getting muted when they come in. I'm gonna see if I change it.
Okay, that's perfectly fine. So the way that this will work, I'm going to be a little bit didactic in the upfront just because some of this stuff is really foundational information, and we'll get into more Q&A as we go forward. But please feel free to put questions in the chat box as we go, and happy to break into a little bit of more live demo towards the end. So we only have an hour, and I know we're 2 minutes in and it's going to feel like really fast and furious. So bear with me on this one. We're really gonna kick up the gear and get rolling. So I want to start with a brief foundation around some things that we'll probably just be throwing around as different terms, and I want to make sure everyone understands what these things are, just so that we're not confused and they all mean the same thing to each of us. So Odyssey as an acronym, if you're new to it, it means Observational Health, Data Sciences, and Informatics. It's a global community, myself and many, many others. There are databases in 21 countries, over 150 unique databases. They have 25 work groups, thousands and thousands of users on our forum. And their mission is to improve health by empowering a community to collaboratively generate evidence that promotes better healthcare decisions and better care. And really, it's a foundational commitment to open science and having innovation, reproducibility, and openness at the heart of it. And if you're curious, you keep hearing this OMOP word. Well, OMOP was an experiment, the Observational Medical Outcomes Partnership. It started just over 11 years ago, and it was a series of various experiments that were funded through a public-private partnership. There were a series of investigators that were part of that, but the funding didn't last forever, and at about 5 years in, it became this Odyssey community, which is now an open community to anyone who wants to join. By all of you being here, technically you are collaborators today. And it's multi-stakeholder, interdisciplinary, and open source. It's international. It's really focused on observational health data and looking at large-scale analytics. And how does this relate to N3C? You guys have probably seen this slide before, but OMOP as a data model is part of the heart of our harmonization process. And we are fortunate to have colleagues from ACT, Trinetics, the PCORNet models, all coming together to bring expertise to ingest these data feeds into a central OMOP that can then be requested for access. And of course, there's a whole process for that. And then why would you use a common data model in general? Well, it's probably worth just saying that there's this idea around how we regularly build one study per one script. So maybe you're writing a study around the adherence of a drug that you're looking at. And you can think of it like having a single appliance in your house. You have an iron that you have for one use case. You use it to iron your clothes. And you can think of that analog as the tool you're using, let's say maybe to answer this question, adherence to drugs. And how that iron plugs into electricity is that application, right? We have the appliance, we have the application, that's what gets power into it. And back in the day when we used to travel everywhere, many of us may have seen that it's not that simple to plug that iron into the wall, depending on where you are in the world. And it might look a little different. And really, this becomes very analogous to how we often do research today, where we write one SAS or R script for each study. It's a bit, you know, it's hacked up. We have these little wires going everywhere. It turns into this spaghetti soup mess of trying to have different ways of getting electricity going. And our scripts kind of look like this. They end up being very bespoke to a data set. Oftentimes they're not scalable because they are written for one type of data or information, one technology stack. And often it can be difficult to read each other's code. It can be very slow and often very prohibitive to non-expert use. But what if there was a different way to do this? What if we didn't just create one script per every study? You can think of data standardization and common data models as a way to take whatever appliance you are looking to plug into the wall and have a standardized way of interacting with that electricity feed. These could be any types of questions. And it can work in this way where analytics can be remote and it can be behind a firewall. So data can stay protected where it is, but we all share the same common structure. And it can compound into a network where we have many nodes and many different types of information in a common data model. And that's really the power of standardization and why we're going to go through some of these concepts today. Because when we begin to share and use the same knowledge model, it really allows us to increase the reuse of our scientific artifacts and to be able to share and have larger, more multi-center investigations. And what's really neat inside of N3C is that we have two worlds. Most of you are going to be on the right, which is you're going to go through the data use agreement, data use request process, and get access to the secure enclave. There's a bigger world parallel to that of other external collaborators who are using the same data model who could share their study design with researchers who are inside of that enclave. It's bidirectional. And really what's quite neat is that by using this model, we have the ability to both do federated querying and centralized analytics. And we're using the same level of granularity and information across these models. It's pretty neat. So that is a little bit about just, why are we entering into this world of common data models? Where are we in N3C, and orienting you a little bit to the groundscape of just the world around you. I'm going to take one step deeper now and get into the topic that's the name of today's meeting, OMOP Vocabulary 101. And you're probably asking yourself, what is the OMOP vocabulary? It's a standardized structure to house existing vocabularies from the public domain. So we'll come back to this in just a second what I mean, but we didn't write this ourselves. We actually took lots of compiled standards from disparate public and private sources. In some places, we made OMOP extensions to help bridge where the ontologies are not quite apples to apples in their level of detail. So it's a standardized structure. It's compiled from terminologies you may already use all the time. But what it's not is static. It actually regularly gets updated. It continues to evolve as those vocabularies evolve. A good example of this is as LOINC approves, as we approve new diagnostics, LOINC will get updated, and therefore new concepts or new codes will come into existence. And of course, that's why it's important we update and continue to maintain this vocabulary model. And it's by definition never a finished product. The vocabulary maintenance and improvement is regularly ongoing, and it's something that we regularly engage with researchers to understand what are the primary use cases and how can we better support research questions. And orienting you to the vocabulary as it relates to the common data model. The common data model has standardized clinical data elements, standardized health system data, there's even metadata, standardized health economics, and standardized derived elements. The standardized vocabulary is the backbone to all of it. And today we're going to talk through how this really works, but it's the tables that allow all of the information that we store in these domains to be interoperable across different types of real-world data feeds. And there are many parts to the vocabulary. It's not just one thing. It has many attributes depending on how you're going to interact with it. But we're going to start from the very bottom, which is the concept. And you can think of the structure of the OMOP vocabulary as all the contents become a concept. Concepts are clinical things that you interact with. This could be drugs, it could be conditions, it could be procedures, it could be biometric information. There will be a concept for that in the concept table. Concepts can have direct relationships with other concepts. There can be things that are related to each other. And then there's also this idea of hierarchies, this idea that one thing could be a more detailed attribute of something more generic. And we're going to dive into this as we go through, but if you think about this holistically, the concept table that you see in the standardized vocabulary, it's really a giant reference table of all the vocabularies that we possibly could find, and we are always adding more, but it's those vocabularies that we use in our source data and a way to have interoperable detail between different data sets. So all the vocabularies are stacked in one table. They get a unique concept ID. They have a vocabulary ID to tell us where did we take that information from. And it becomes this very long enumerated thing, but you'll interact with it in a number of ways. If you're in the data, that concept becomes an attribute that has many things that you can use to then get more information. So what's in a concept? You have a concept ID, which is the unique identifier that we gave that single concept in that big OMOP concept table. You have its name, which is just really a string. That's kind of the English description. There's a domain ID, which relates to where does it belong in the common data model. There's a spot for that attribute of what vocabulary did that concept come from. There are classes. This actually comes as part of the vocabularies themselves. Concept class ID will be fed. You'll also things like clinical finding. You'll see a spot here around a standard concept, and we'll come back to this in just a minute, but this is an attribute to know, is this the interoperable way of sharing this particular clinical term, or is there something that is something else? And so we'll come back to this idea of standard concepts in a minute. And Andrew, maybe I can ask your help with the chat. Can you help keep an eye on the chat and maybe tell me some of the questions that are coming in?
Yep. Would you like to take questions as we go or after the presentation?
I'm happy to take them as we go. I'm going to finish the thought of just what we're presenting on the slide, and then I'm happy to kind of answer questions per slide, because I do think some of this stuff can be very abstract, and I promise it gets a little crunchier as we go. So if we think about the remaining attributes in a concept, you also have a concept code. This is actually the coding from that vocabulary. So you might be saying, what's the difference between a code and an ID? Code is what we took from the vocabulary. Concept ID is the unique identifier that we gave it, because as you might imagine, codes are not always unique and they can be repeated. So we needed a way to have unique records, and that's why you have concept ID, where we make sure that it is not duplicative of another vocabulary. You'll see things that say things like the valid start and end date or invalid reason. Generally speaking, this is intended to help create a way to keep track of when vocabularies update or allow new terms to come in. Sometimes some codes have been around for a really, really long time, so they look non-informative. Atrial fibrillation has been around for a very long time, and therefore the start and end date are essentially from the beginning of when we kind of started time in concepts to the future. And you might say, well, gosh, that seems kind of silly, but the valid end date, the reason we set it for an arbitrary date in the future is, one, because our children can be the ones who have to figure out when this concept expires. But joking aside, it's actually because the concept is still valid, so we just put a future date. You won't use this too much, but it's just there in case you're really curious about the lineage of terms or depreciation. And all of that is, of course, attributes we want to keep track of. So we'll pause for just a moment. And Andrew, what kinds of questions are being asked at this point?
Yep. So what's the difference between a concept ID and a source concept ID?
So a concept ID is the unique identifier we are giving it in the OMOP concept table. A source concept ID is the coding that came from that source vocabulary. So an example would be in ICD-9, you would see the concept ID as some number that we gave it as it exists in the concept table. And then the source concept ID will be, 427.0, whatever you know it as in ICD. So that's the relationship of the two. They're intended to maintain the provenance of how it's captured in that source vocabulary, but also give it a unique identifier because, as we were saying just a minute ago, there's a lot of times when concept IDs get reused across vocabularies, and so the concept ID exists as a way to make sure we kind of keep track of that.
And then how frequently do concept names change? Is there like a set interval? Do they...
Concept names, I wouldn't say they change that frequently, or at least it's a string that is somewhat stable. They're more, the things that change more often are new records of concepts. And maybe perhaps a vocabulary might refine its descriptions and you might see updates, but concept names tend to stay fairly stable, but we don't generally search on strings because the concept ID is a unique, basically a primary key, and it's a lot more reliable than a string that may get used across many different terms.
And then I'm going to give you a two-parter. So what's the difference between a domain ID and a concept class ID? And then how are concepts identified in the matching? Is there a validation?
Yep. So domain ID really is a place in the concept table that says, where does this vocabulary belong in the standardized clinical data elements? So I showed you a schematic, but I'll show you a little bit later. There are specific domains in OMOP, and you might hear us say, depending on what calls you've been with me, oh, I didn't choose which domain it went in. The concept table told me that. So the concept table is kind of our Rosetta Stone that tells us where this term belongs relative to what the table is supposed to be capturing. The concept class ID is an attribute that is populated from that vocabulary. So clinical finding is a great example of, it's actually part of SNOMED. We're just keeping the attribute. In LOINC, you'll see things like measurement value, MES value. So we don't make the concept class ID, that kind of comes from the vocabulary, but the domain ID was something that became kind of part of the concept creation. It's just how it's instantiated. And sometimes domain IDs may change over time if convention changes, but that's somewhat rare. But it's really this idea of helping you know that this concept belongs in this place, because when it comes from your source data, it could be in any table. And what we were trying to do is make it easy for you to go from that table in your, let's say your Epic Clarity, and find it a home in the common standardized clinical data elements.
Could I ask a question about that?
Sure.
So here's Peter Robinson. This actually seems to be a mistake, because at least I would interpret condition as a disease, but SNOMED says this is a clinical finding. And so are diseases, for instance, genetic diseases, primarily characterized by atrial fibrillation, and they're called atrial fibrillation. But there are many, many other diseases that have, among many other features, atrial fibrillation. So, I mean, you're actually misusing the SNOMED code for a condition here. Or is
Thank you,
that?
Peter. I appreciate the commentary, and I think it's really valuable. It probably is a little limiting to look at it in this view because we're not actually looking at all the attributes. I'm just kind of describing what a concept is. In the vocabularies, you'll see domain ID. Disease is not a domain in OMOP. It is condition occurrence, and we're going to get to that a little bit later. I'm happy to come back to this point as we go through it. I think as we go through Athena, it will become a little bit easier to see more attributes of what's available. We are very much limited by the fact this is a PowerPoint slide, and I'm not even pulling into the relational nature of these tables. And strings can be truncated in views, right? This is just an example of how this exists in time and space. And Andrew, are there a couple more questions? I do kind of want to move ahead in the topic. I know
Yep.
we're not going to have a ton of time today, but I'm happy to continue commentary as we go.
Perfect. And then for folks too, this is recorded. We'll get the slides out. And then if we need to have a follow-up, a 102, maybe we can definitely do that as well.
So keeping in mind, the intent of this slide is to show you what's in a concept. It's important to then move into this idea of source codes, concepts, and mapping to standard concepts. And this is really where we go from how your data starts in a source vocabulary to how it becomes into a standard. So the source for source codes, they may come from an international terminology or coding system. They may come from a country-specific terminology or code system. So great examples would be read codes in UK data, CVX, that's vaccine data from the CDC, ICD-10-CN is Chinese ICD system. So source vocabularies can be very specific to what's used in practice in an area. They could be free text strings. They could be things related to the measurements or routes of administration. And they may come from an EHR specific coding system. And what I mean by that is that sometimes when things are coded inside of your EHR, it's very specific to that EHR vendor. It's done in a very systematic way. And that may be something that becomes its own ontology that can be mapped. And I'm hearing a little bit of background noise, so I hope folks can mute a little bit. But when we talk about these words, the idea of non-standard to standard and even classification, it's really different categories of concepts. A non-standard is the unique representation of that source code from that source system. The standard is really that code that we use that is the standardized analytics way of representing that term. It'll be used in how you build concept sets, how you build cohorts, and how you even run studies. Classifications are really concepts that allow you to do hierarchical querying. So an example could be the ATC hierarchy, or you can even use different levels of SNOMED. You could go up in the SNOMED hierarchies as well, but that's a little bit different. So the idea is that there are different categories of concepts, and it sometimes really depends on where it comes from in your source system. And the mapping of a non-standard source concept ID to a standard concept ID is really this one direction. You start with a source concept ID in a vocabulary that is not deemed as standard, and you have a relationship then in the concept relationship table that is maps to that tells you what the standard concept is for that non-standard term. And this makes a lot more sense when we look at examples. So if we think about mapping source codes or source concept IDs to standard concept IDs, you can think of starting with this idea of what source code is available in the Odyssey supported vocabulary. So there are many different source vocabularies that we have available, but if you are starting with a term like malaria, and you have a source code of 614620000. You could be able to use a statement. If you had access to the tables, you could actually query where that source code is equal to a concept code. We were mentioning the difference between concept codes and concept IDs. This is really where it's handy. If you can access the concept code table and you know what vocabulary you want to, what vocabulary it's represented in, you can then find a concept ID. You could do that as a query. Or you can actually use Athena. So athena.odyssey.org is a visual browser that allows you to be able to essentially do the same thing you just did in SQL, but in a user interface. Athena is built only using the vocabulary tables. And what this means is that it will tell you information about how a concept relates to other concepts. It'll give you synonyms, information about standard, non-standard, but it won't tell you how much this term is used in a database. That would need to be done on a tool like Atlas, which actually has counts of concept usage. So this is just purely an external way to look at the concept tables and it's very nice. It's a user interface. I'm going to flip over there for here. Now you can see. So if you were searching, let's say you don't have the concept code, and how would you get here? If you go to athena.odyssey.org, you'll end up on this page. You can search in strings. You could search something like malaria, and you could look through and see different terms. This will give you all terms that have a concept name that's similar to the string that you've entered. But more specifically, you might say, I know I am looking for a condition. And you may say, I know in my data, I'm using SNOMED, and this is actually the term I was looking for, 614620000. You could easily enter this integer. You could just start there and go either way. And of course, there it is. And this is a great example of why concept IDs are so important, because there are actually multiple vocabularies that use 614620000. So the concept ID here is important because it gives us that unique record. And in this record, you can now see, very similar to what we were just looking at, what's in a concept. You'll see the attributes of what this concept exists in the concept table. But you'll also see information on relationships. And there's two ways to view this. You have the related concepts, which takes the relationship table and tells you information about, is it a causative agent or a pathological process using SNOMED. It could tell you other non-standards that map to it, how it relates to other standards. And this can be a very long page. It can even tell you how it subsumes information. You can also, if you're more of a visual learner, can actually click on the hierarchy button here. And in a moment, it'll render with basically a lineage. And I will say this is biased. So this the system, it does better on Google Chrome. If you're on another browser, you may have performance issues. But on the hierarchy tab, you'll see, it's a little bit harder to see, but it shows you all the things that are more detailed than that concept that you're looking at. So malaria is at this level, but there are actually more specific terms that you could be using. And there are also less specific terms. You can go up the hierarchy to things like your protozoan infection or disease caused by parasite. All of this is coming from the use of these concept relationships. Athena is a really great way to get your hands on touching and feeling the concepts. You can search lots of different types of concepts in here, and there's a lot of opportunity to also just explore. Perhaps you don't know the term you're looking for. You can actually just start by exploring a single domain. And you have the ability to even further restrict. Perhaps you are working in a specific source vocabulary and you want to see what terms fall. If they're grayed out, it just means that they don't apply for that particular domain you're looking at. And of course, there's information on standard and non-standard. And really, this is a great way to begin to just start to get comfortable with understanding what you could query. So I'm going to go back to here. And now that you guys know where the site is, you could, on your own, look up Zika fever and see if you can go between source code and find its concept ID. And how would you do that? Well, you could search in Athena this source code right here, A663D00. You could search the code description. And if when you're there, you could filter on the read vocabulary. And in that first column in the UI, as we saw before, you would see the concept ID populated. It'll just say ID. I'm gonna pause for just a moment, Andrew. I can see the chat
Thank
box
you. Yeah,
exploding.
quite a few questions here. So are the concept relations only captured amongst standard terms or also amongst non-standard ones?
So they're definitely, so you have to kind of go up the hierarchy to get the relationships. When you start as a source code, you're starting at the lowest level of the hierarchy, and you have to find its standard. So read is a great example. Let's look this one up. So read code, let me just see. I think I would know it off the top of my head, but I don't. So this read code for Zika. Let me get rid of that. There we go. So this is the first one. So this is a non-standard, and you're going to see that in a couple of ways. It says concept is non-standard. In Atlas, if you were searching, you might notice it's like a burgundy color. That's just a way to visually cue you that this is not the interoperable way of representing Zika across databases. What you would have to do to take advantage of the relationships. So if Zika is what you're looking for, if you see this is a non-standard code, but it maps to a standard, Zika virus disease. Once you're in the standard, we've gone from non-standard to standard, then all of the hierarchical information will be exposed. And so it's a little bit of one direction. You have to go up a step to get all this information, but you're not you can still access that. You just have to know, you have to say maps to, and then once you know what it maps to, all of that is just that level of detail above it. Does that make sense?
I'm going to say yes, but I believe Sean O'Neill asked the question. Did that answer your question, Sean?
It absolutely does, yes.
Cool.
Thank you.
It gets easier, I promise. Like, I know it feels really painful to go from non-standard to standard. Think of standard as the thing that relates all these disparate representations of the same clinical concept. And of course, when you're using standards, you also get the beauty of once you're in the standard, you can then inherit all of the descendants of that standard. So more detailed representations. And this would be, in this view, you see it says subsumes. You'll see other things come up, other non-standard maps. These are other source vocabularies that map to that standard. And so this is probably the hardest piece of getting oriented to the vocabularies, is just learning what a standard and a non-standard are. Andrew, are there other questions kind of in this vein?
There's just one posted here. Can we do 1 to 2 basic examples with drugs on this call, specifically the drug exposure table in the N3C enclave? For example, there's a couple questions here then. So let's maybe just take that.
Yes, you're stealing my ending. That's like a couple slides from now, but I will come back to that. So we will go through drugs in just a second, because it's true. Drugs, I think, are even harder. So if this is starting to make sense to you, this idea is this term that you use locally, your source code, it can be a way that you search for and find the standard. And you could do this in SQL against the vocab tables, or you could just do it with one of the UI-based tools like Athena or even Atlas. And I'm not going to beat you over the head. I think you guys are getting it. So you could do the same thing for West Nile virus. And I'll share these slides, so you're welcome to go through them at your leisure. I want to come back to this idea of what happens before we go to drugs. Just what happens when I have a source code that's not a full, it's not an integer, or it's not something like an ICD-9 or read code. So you can still search the source string to find the standard. So if you were using something like centimeter and you wanted to find the standard concept, you can actually do that. So you're not restricted to mapping just from, these kind of extremely structured integer sources. You can actually take the string and search, and it has a concept ID associated to it. And so this may come up in, as you look up ways to standardize units, as you look up routes for routes of drug administration. Of course, in demographics, this happens quite a bit. And it's the same idea. I could go into Athena and just type in centimeter. And now I can see this is the UCOM vocabulary. This is centimeter here. I see there's other things about centimeters, but I can actually search those strings and find other things about units. I can see relationships between different ontologies. So that's also available. And you could do this for each of these. But since you guys asked, we can move on to the idea of, so drugs will be after this one, but if you are curious about what happens in the world between that, what happens if these strings or the codes I'm using do not cleanly map into a supported source vocabulary? Then maybe they are very unique to my EHR installation, or maybe it's a homegrown ontology. So Odyssey has a process for this, and there is ways to get custom codes to be included. If you actually go on Athena, you might even see vocabularies that look like the name of someone's database. And that's because we actually worked with those data owners to create a supported source vocabulary from that data, and now it's in the concept table. So that's available. It's certainly an option. We've been talking about creating potentially an N3C one for things we see as we're going through harmonization. We're still working on that, but I know Devira is keeping track and keeping in touch with our vocab team. There's also the opportunity in some people's data, they do what we call the billion series. They just create records in the concept table for the source data that does not map cleanly because it's not in a supported source vocabulary. And if you're really curious about this, at the Odyssey Symposium in 2 weeks, there will be a full poster from Melanie Filofsky explaining this methodology. So there's a lot of work that goes on here, and I can't do it justice in an hour, but I can promise you there's a lot of support for when things fall in that in between and you can't find a concept. And it's really important to think about these other relationships, right? The hierarchical and part of relationships. And the hierarchies are really a way to organize information. And you'll see things like we just saw in the concept in the concept records in Athena, but you'll see things like is a, map from, maps to, subsumes, due to, focus of. These are different ways to relate clinical information across vocabularies and even across concept classes. And we talk a lot about this idea of the ancestor and descendants. And the simplest way to think about this is ancestor and descendants have to do with the level of detail that you're looking at in your particular source data. And what that means is that you can have different information and different levels of detail, and descendants may just be a more detailed version of its ancestors. And relationships are bidirectional. Things can be mapped to and mapped from, is and subsumes. And the entity relationships are really these maps to value. This is all the source vocabularies provided by our source or built by the vocab team are mapped to themselves, just creating that record and that instantiation of that entity. Part of relationships are these controlled, well-structured ontologies like RxNorm, SNOMED, LOINC, ICD-10, PCS. And you might see part of relationships represented through things like has direct procedure site, has method, occurs after. Those are all from those ontologies. Hierarchical then is really things like our ATC, ETC, CVX, and DFRT. If that's just alphabet soup to you, you can think of it as these is a relationships or panel contains relationship. And why I preface this before we get into the drugs is if we think about how, you know, a vaccine goes to RxNorm, that's the CVX RxNorm hierarchical relationship. All of that's in your vocab tables. And so what's really quite neat is you have a term, like let's say you're looking at transplantation of the heart, and you can have a lot of relationships off of this. You can have has a direct procedure site, has method. It could be actually following other concepts. It could occur before another concept. And it can even have a SNOMED CPT for equivalency. All of that is part of how we relate information. And of course, LOINCs are a big part of what we're doing in N3C. And we can think about how LOINCs can have contained in a panel, has a property, has component, or even has system from an individual test. And of course, the panel itself can contain attributes as well. All of that is appreciated in the way that we structure concepts. So nothing is lost, it's all there to query. And these attributes may be there to also make your job easier to help you find the things that has property or has component. And of course, today we're not going to be able to go into extreme detail on how to do this, but I bring this up as a way to help kind of to give you an idea that there are lots of additional detail we can provide, and we're happy to come back to this in a more advanced class. So the ancestors and descendants really look like this. The higher level of relationships. We have disease of the cardiovascular system at the very top, and at the very bottom, you see things like chronic AFib, rapid AFib, permanent AFib. You know, those come to that level through lots of descendants, through lots of hops and skips. So I can go from disease of the cardiovascular system as it relates to AFib or heart disease to AFib. All of that's there in those ancestry relationships. And those are concepts that have concept relationships. And then there's these ancestry relationships, which are really degrees of separation of those concepts and concept relationships. And so your ancestors and descendants have multiple levels of separation, and the number of levels of separation just really is between what level of detail you are to where you're going. And in the data, you may look through and utilize this. If you're in the tables, you'll see min level and max level. That's where you started. It'll give you information on where you're going. So you'll see the numbers increase. And min level and max level really just says what's the number of hops and skips to get from this concept to its relatives. So you can think of it as how you're related to your parents or your grandparents or your great-grandparents. And so somebody was asking about drugs, and I didn't want to hold it too long, but I want to start thinking of concept answer and concept relationship. So if we look at glucocorticoids, we have prednisolone, and we have the ability to go up and down from ATC, RxNorm, all the way through to the trade names in some cases. And this is all attributes that are both in the concept name as well, by having the relationship between concept name, concept ancestor, and having these levels of separation. And I realize this is a lot. This is a lot of detail. It can be quite complicated. So it probably makes sense to show you an example, but I'll pause for just a moment. I guess, Andrew, are there any questions that feel opportune to insert before we kind of switch over to the live action sequence?
I don't see any questions, but Zidong, you're called in on the phone, and I think we're getting some feedback from you. You appear muted in Zoom, but you keep getting highlighted. I think we talked through this other question. And folks, if I'm missing your questions, please put them in the chat and we can get them answered after the meeting as well.
Thanks, Andrew. I appreciate you reading the chat back to me because I'm trying not to mess up the windows too much. So yeah, please keep asking questions as we go. I know there's a lot of things we want to go through. So I will make sure you guys have these after the fact, but just a reminder, this is really what we were talking about from the beginning. Source codes go up into a standard, and sometimes there's low-level concepts all the way to top level, and there may be classifications that further organize that. And that's where the standards come in. They're that grain of information that goes from the most detailed information in your source system all the way up to these classifications and top-level classifications. And so I'm going to skip ahead to the drug hierarchy. So it's important to think about drugs are really tricky because there's a lot of information that we capture on them. And there are so many source codes in comparison to some of the other domains. And what we really want to do is go from how it's captured in the source system, maintain that in the source concept ID, and map it to the standard concept. And this could be to a drug product, to a drug form and component, to an ingredient, and then maybe even to classification system. And then really honing in on this, you see that it says RX norm extension. RX norm is the majority of what you will interact with. In a very small subset of US data, you might find RX norm extensions, but this is really more for our international collaborators who may have molecules and especially forms and components that are not supported in RX norm. So OMOP has built RX norm extension as a way to relate that information. But generally speaking, in our data, we're kind of more on the left. And you, of course, can capture not just active drugs. We can also capture procedure drug administration, and that's part of this hierarchy as well. So if you want to think about your drugs with an ingredient, I'm just going to show you the way to do this in SQL, and then we'll go into the Athena user interface in a second. But the idea is you can start with a concept like warfarin, or you could use clopidogrel. But let's say you use warfarin, that's on the left. If you know the concept ID for warfarin, you know you can then utilize the ancestor and the levels of separation to find other information that are associated with an ingredient. And this is where concept classes are going to be populated from these vocabularies. So you might see things down from branded dose group to the clinical drug. You might have just the ingredient. But the idea would be you can utilize the max levels of separation to go from ingredient to all the things that relate to it. And so let's go into Athena in just a moment. But if you think about how monotherapy drugs, if you wanted to search for them, if you were going to search for metformin, you can actually utilize in Athena, you can actually filter down and look at clinical drug form. You can filter it to just the standard. You can obviously restrict it. It should only ever be in the drug domain at that point, but you can add those filters. In an atlas, you would maybe use the same exact terms to create a concept set like metformin. And why would you go through the hassle of creating that concept set? Well, you may want to roll all these things up to be your representation of what you're looking at in metformin. And you may want to use it then to do some counts about drug strength or concept ancestors or even the descendants of the clinical dose form. And so you'll use this information both in terms of maybe how you create concept sets, but also just how you traverse going from an ingredient to these other pieces. So I'm going to pull up Athena while we're chatting, just to give you an idea of what we're doing live. But
we do have a couple new questions whenever.
Yep, absolutely.
We have a couple new questions. So is the concept ID mapped to UMLS CUI?
The concept ID is uniquely the attribute that has been given in the OMOP concept table to map it across vocabularies. Like if you're going to try to map it to a UMLS CUI, you can't see it in the public view. You could utilize some of the attributes, but it's not the same identifier. So it's actually literally an arbitrary value that OMOP gave it, but it can be related to other terminologies through the concept attributes, which might sound a little confusing, but does that make sense? UMLS CUI would be its own ontology. That would just be a record in the concept table.
And then can you have multiple concept IDs mapped to the CUI? The same CUI?
I'm not as familiar with the CUI, so I'd have to come back to you on that. It would be helpful if you had an exact example. I can go through it to you. Generally, when we talk about it, it's really, you have your concepts will be mapped to things at the same level of detail. If something is more detailed, you might have a one-to-many. And I don't have enough familiarity off the top of my head to tell you if that's the case, but I'm happy to follow up on that.
Sure. And AJ, if you have some other examples, feel free to put them in the chat and we can address if there's time. And then how much classification is being done by the sites and how much is being done by the N3C folks?
That's a great question. I guess I think I saw Devira and maybe Emily's on. I think that's really on the analytics side of things of how you use the vocabularies. I don't think anyone is making choices per se, other than I think in the cohort paper, they're developing their understanding of what they want in hierarchical relationships.
And then was the figure, which I think was right before you launched Athena, did that come from Atlas? And that would be the last question we have.
Yeah, so I'll pull this up just to show you. So these are actually screenshots of this idea of trying to relate these worlds together for you, because I can really appreciate some of you have been playing with the public tools and maybe like, what are the differences here? So the idea would be Atlas on the right. This is actually where you build concept set expressions. You capture the things you see on the left in Athena, which are just records and information about those concepts, and you can actually use them and create them into little concept sets that you can then pull the descendants and pull them into a JSON that can be put into a cohort definition, that can be put into a study design. So they relate to each other. They're a little bit different, but what we want to show you is that you may use them interchangeably, where you start asking questions like finding monotherapy drugs. You want to look through and investigate things that are in a clinical drug form. And sometimes it's a lot easier to do this in Athena because it's built for the use case of traversing the vocabulary quickly, whereas Atlas is built for study design, and it's sometimes a little bit harder to see these things. So they're just two tools in your toolkit that you can use for that. And I guess in the interest of time, because we're not going to be able to go through everything, and I know this will always happen, there are going to be some examples of how you go through members of drug classes by using, let's say, the ATC hierarchy. That's an ancestor that you could pull, and you could then look at the concept class ID and the levels of separation. And you can really work through even on members of drug class, and you can even look across different concept names to understand the attributes there. So somebody was asking about concept name representation. It will always depend on how many characters you can see on a screen, but some of these concept names can be quite robust and are much longer than a single attribute. And in RxNorm, you might see things like the clinical drug form has the hydrocortisone and that clinical drug form appended to it. So all those attributes are available to you. It's a lot of information that you can take advantage of in your querying. There's a lot of different ways you can take that to create concept sets. And I see more chats popping up, so feel free to interject. But really, the idea across domains is each domain will have different nuances on its hierarchies, and they're not all created with the same vocabularies, because it really has to do with what clinical information is represented. So the measurement domain supports SNOMED and LOINC. We have some examples here of how a glucose measurement would exist in the measurement domain. And what informs how these hierarchies go into practice is really what was in the source data and how do we map that to the standard, and then that information will tell us what hierarchy is applicable. And there's
Harold's been
yeah,
answering the questions in chat, but if anyone else does have questions, please put them in, and then we are up on the 5-minute mark. So if there's any last questions, please get them in.
And so you're not going to learn absolutely everything there ever was today because it's just impossible to learn at OMOP in an hour, but your crash course slides are really going to help you get a little bit more familiar with these hierarchies. I know some of you have sent me notes asking how to traverse going up and down. And so hopefully this will give you a little bit of a roadmap. And in the last couple of minutes, I just want to orient you to this idea of the vocabularies, as we were saying in the beginning. They're a piece of a larger puzzle. They're really the way that you're going to create records and take those records and then go across the person. So the person ends up being the thing that links everything together in the standardized clinical data. And we'll have whole other classes on how to use the CDMs and how to come back to that. But it's really important to get familiar with what the concepts are that you want to study, understanding if it's a source or if it's a standard, because that'll become your building block to everything else that you do. And the CDM, as I said, is person-centric. It's domain-oriented, which is why it's really important that domain ID is something you begin to get more familiar with. Most importantly, as you look at the structures, it preserves data provenance and source data. So the whole purpose of source concept IDs and standard concept IDs existing in parallel in a domain is to give you transparency into what was it represented in the source system. And the standard is, what is that interoperable level of information I can then query across other databases? They're both there for you to use. They are available to be extended if there are gaps in the source vocabularies, as we were saying earlier, happens all the time in EHR data. And a huge shout out to Michelle Morris and Emily Bath and the whole Phenotype team who continue to bring use cases to us that help us understand where we could improve our vocabulary mappings. And if you're curious about version control or you just really want to get into the details, there's some great documentation available for you. And Claire Blacketer, who's a part of the N3C community, is also available to answer questions. We'll come back to the CDM piece in a future lesson, but I want you guys to walk away today with, there's a whole wiki that she just updated. It's brand new in that she's added more detail. So if you want to get into the weeds of not just the clinical tables, but also understand the sentiment of those vocab tables, feel free to go to this wiki. It's really, really detailed and even has information on the derived elements, the metadata. This is a wonderful resource. It's extremely robust. Could take you many, many hours to read through all of it. It's quite a bit of documentation. There's also a whole chapter in the Book of Odyssey on how standardized vocabularies work, which then goes through the concepts, the relationships, the hierarchies, and some examples. So if you walk away from this and you're like, oh my gosh, I'm so confused, I don't remember anything, this is available to you for free, bookofodyssey.org, book.odyssey.org, and you'll be able to go through that in your leisure as well. And I see there's a poll. Should we have a second class? Probably. Everyone always likes to go to class, right? Well, these are also, there's opportunities you can ask questions on the Odyssey forums, forums.odyssey.org. There are work groups. There are weekly Odyssey meetings that meet every Tuesday between 12 and 1 Eastern time. They're open to everyone. There are studies and study-a-thons coming up. Andrew Williams is leading a study-a-thon in 2 weeks. That's a crash course in how to really get your hands dirty on running with these concepts in practice. And all of that is available to you. So I know we're at the end of time, and this is probably pretty fast and furious. And I just want you to know you have the support of a whole bunch of people behind you, and we are so happy you guys are beginning to learn this information, and hope you'll continue to join us on the journey and get immersed in this, because we love collaborating and creating more science. So I'll stop there, Andrew. I talk a lot.
That's all good. Thank you so much for putting this together. The poll seems to be very clear, indicating that we should do a 102 vocab training. So we'll get that set up for folks. I'll be sending this out to all the domain team mailing lists for the recording and also the slide deck. And then if there's any other questions, feel free to either email Kristen directly or myself, and I can help try to facilitate. So thanks, everyone.